Hello, everyone, and welcome to today's webinar. We appreciate you taking time out of your day or evening to join us. My name is Sherry Sullivan, and I'm with the AWS marketing team here in Seattle. I'm pleased to host today's webinar where you'll hear from AWS and Optaros, one of our advanced consulting partners, who will share their expertise delivering digital commerce for global marketers. Let's get started with just a few housekeeping items. The duration of today's webinar will be approximately 1 hour. The lines have been muted. However, we will take Q&A at the end of this webinar. We also invite you to ask your questions via Twitter at #AWS Optaros. We'd like to remind you that today's webinar is being recorded, and we will provide a link at the end of today's session. In addition, you may visit us at AWS channels on YouTube and SlideShare for the slide decks and the webinars on demand. Today's session begins with Simone Bruzzoni, with one of our AWS technology evangelists. Simone will provide you with an overview of e-commerce on the AWS cloud, followed by Kevin Carlson, who is a senior director at Optaros. And Kevin will share a deep dive on best practices for running e-commerce in the cloud. So without further delay, I'd like to turn it over to Simone. The floor is yours.
Thank you very much, and good morning, everybody. I hope that you can hear me well. I'm actually in San Francisco today, so I'm remotely connected. And today I will talk about doing e-commerce with Amazon Web Services. Of course, we're going to have a Q&A session. We're going to accept questions also from Twitter. If you are on Twitter, I'm Simon on Twitter. You can just send me a direct message or mention me on Twitter, and then I will read the most relevant questions and try to answer them along the way. Everybody can confirm that you can hear me well?
Yes.
Okay, good. So first of all, Amazon.com is a big company that does many things, and you are probably very familiar with many of those things, such as the Kindle or the cloud players or Cloud Drive and other things. But of course, Amazon, we like to divide it into three main categories or three main columns or branches. The first one is the consumer business, the one that you know the best, the one where you go and shop and buy things. We have a second branch, a second part of Amazon, which is called the seller business. And in this particular case, we enable third parties to sell their items and their products through Amazon.com. And then we have a third branch, what we call the Amazon Web Services. And essentially here we are providing cloud computing services to our customers. So one question might be, how did Amazon, which used to be a small bookstore online and then turned into a big online retail, how did Amazon get into cloud computing? Of course, there are many reasons for this, and essentially Amazon invested a lot of time, effort, and money in developing a distributed service-oriented architecture. And after a few years of doing this, we realized that this could be a good value proposition for our customers, and then we decided to offer those services to the public. And the main benefits of cloud computing, and sometimes people refer to this as utility computing, is that you get resources on demand. You pay those resources as you go. For example, if you rent a server now and you use it only for a few hours, you would only pay for a few hours for that server. There's no initial investment, no commitment, no termination fees. So that's why some people refer to this as utility computing. It's available and it's also distributed, which means it allows you to build high availability architectures by running multiple machines across multiple data centers, even if you want across multiple regions in the world. And it's uniform in the sense that we provide a general purpose platform that comprises multiple building blocks. You can take those building blocks and then use them as you want it. For example, you might say, I need some servers, so you will use what we call Amazon EC2. I need some storage. You can use Amazon S3. And then maybe you need a content distribution for the content of your website. In that case, you would use Amazon CloudFront. And you don't need to use the other services if you don't want to. So you pick those as if they were Lego blocks, and then you assemble them together to create the architecture that you want. So a few words on Amazon EC2, since it's one of the most popular web services that we provide. EC2 stands for Elastic Compute Cloud, and it provides you with virtual servers on demand of different sizes and different performance types. For example, the small machine has 1.7 gigabytes of RAM, has only one compute unit, and you can go up to the quadruple extra large machines, also optionally with GPU support. And in that case, we're talking about a very powerful machine. You requisition those machines on demand, and of course, there are many other ways to save money by using reserved instances or spot instances, but we are going to talk about this later on. The second service that is very popular is Amazon S3. S3 stands for Simple Storage Service, and as the name implies, it allows you to store files on the internet. Those files by default are private, but of course you can make them public and use them, for example, even to host a simple static website if you want to. We release a few metrics about our business, and one of the most interesting stats is actually the one that relates to Amazon S3. In S3, we have objects. Objects are the equivalent of files, and every object is replicated multiple times across multiple data centers. So if you look at the number of objects that we store in Amazon S3 on behalf of our customers, we recently, on June 12, 2012, so about 4 months ago, we surpassed the 1 trillion mark. So we now have more than 1,000 billion objects stored on Amazon S3, and we reach peaks of more than 750,000 transactions per second. This gives you an idea of how big the scale of Amazon Web Services is. And S3 is also designed for durability. We always struggle to name all the nines in this number here. So we offer a durability of 99.999999999%, or 11 nines. This roughly equates to, if you have 1 million files, of losing one file every 100,000 years on average. So it's a pretty impressive durability option. And what Amazon Web Services excels at is really that it allows you to turn on and off your cloud resources. And of course, when you stop those resources, when you stop a server, or when you delete files, you actually stop paying for them. Let's quickly talk about security now. Because given this is a remote service, given that you cannot touch those machines with your hands, most of the time, especially at first glance, people are usually worried about security, and they have a lot of questions about security. So I'm happy to share with you that we have many certifications and compliance in place, and those are, of course, to make customers trust the security mechanisms that we have in place. So, for example, the SAS 70 Type 2 or the ISO 27001 certifications, those are audited by third parties, and the audits are, of course, continuous. So we get audited every 2 weeks or every few months, depending on the type of certification. And in particular, which should be relevant for this specific audience, we are also the first cloud provider to become PCI DSS Level 1 compliant, which is, of course, related to online payments. As I was mentioning earlier, we have a worldwide reach. We have so far 8 regions in the world. One of these regions is called GovCloud, and it's specific for government agencies. The other 7 regions are open to any customer of AWS, and we have 3 of them in the US, 1 in South America, 1 in Europe, 1 in Singapore, and 1 in Japan. And every one of those regions offers multiple data centers, and we map those data centers into what we call availability zones. And we do so because we want to allow customers to design and architect their infrastructure for high availability and take advantage of the physical isolation and the redundancy in connections for those different availability zones in the same region. And of course, data centers in the same region enjoy a very fast connectivity between them, so it's easy to deploy multiple servers across multiple availability zones in the same region and obtain high availability without suffering from latency. And we also have a network of edge locations. It's 35 as of now. There is one latest addition in Madrid, which doesn't appear in the map. And those edge locations are what we use to offer the content delivery network service called CloudFront, as well as our DNS service called Route 53. So you can guess that we really operate at a large scale, and we also have customers that operate at a very large scale. One good example is Netflix, which a few years ago started to move everything to Amazon Web Services, and now it's almost 100% on Amazon Web Services. So it's impressive to see that a company the size of Netflix is actually running almost 100% on a cloud infrastructure. One of the recent services that we launched is called Search or Cloud Search, and it allows you to essentially do what you can guess, what the name implies. For example, when you go on Amazon.com and you are searching for things, you are accessing a huge list of items and things, and sometimes you want to provide a search functionality for those items. That's why we introduced Amazon Cloud Search, which is a fully managed search service that you can integrate within your own e-commerce platform. And this is particularly important because you're probably familiar with A9, and A9 together with Amazon Web Services decided to craft and build this service here to essentially democratize search. So as of now, if you want to do search by yourself, it's pretty cumbersome to go through the configuration of machines and setting up and software configurations and building other services that need to integrate with search. But if you want to do it with Amazon Cloud Search, it's essentially a fully managed search service that you can you can set up and run in less than 1 hour. And of course, we provide automatic scaling for data and traffic, so you don't need to worry about scaling your infrastructure to provide search. We do this for you. One other interesting aspect that is now enabled by a flexible cloud infrastructure is, for example, user analytics, which is, of course, a very important aspect in any e-commerce implementation. As an example, if you have two different set of customers, young kids accessing your application on iPads or tablets, and maybe not so young people that are accessing the same type of application on tablets, of course, you might want to be able to run user analytics analysis and try to understand what those customers are doing. And of course, you can do those things. For example, the A/B testing is one of the common ways to understand what works better for different types of cohorts or different types of user groups. And if you want to do this, it's easy to set up an A/B testing infrastructure in the cloud, because you essentially replicate the same infrastructure one or even multiple times, and then you perform different tests based on whatever strategy you want to use to separate different groups of users. And as a result, if you look at Amazon.com itself, for example, we have recommendations and we have targeted ads in our website, which of course are a result of these different types of user analytics. So another very important aspect is what we call prototyping, and we also always share this almost embarrassing web page, which is the first original Amazon.com web page in 1995, and this is how it looked like. And of course, you're probably very familiar with how it looks like today. It's a much better, much more complete web page with many details and many different items and parts all integrated together. So we've been able to do this by prototyping different solutions and different types of web pages, designs, and layouts and colors. And of course, it's very important to be able to do this prototyping as effortlessly as possible. And of course, when you have a flexible infrastructure that you can just launch and run and deploy and potentially even turn off when you don't need it anymore, it's really easy to prototype different versions of your e-commerce website or other services and see which one works the best. And just using the words of Joy Ito, which I know personally is an amazing entrepreneur and innovator, he essentially says that if you want to increase the innovation rate in a company, you just need to lower the cost of failure. And of course, by using a cloud infrastructure instead of bare bone metal, you don't require the usually big investments that are needed in a traditional infrastructure, but you can easily validate ideas and try out new things, essentially spending just a few dollars at a time, because you can launch servers, use storage, even for just a few hours, and pay only a few dollars for those, and prototype as many ideas or new services as you want. So in essence, you're able to focus much more on your business and almost forget about the minutiae or what we call the undifferentiated heavy lifting associated with running a cloud infrastructure. So this is all I wanted to share with you today. I decided to make it short so we have some extra time for questions. I will now take a quick look at the questions that you posted on Twitter. And of course, in the meantime, I want to introduce the audience to Kevin Carlson. He's the Senior Director at Optaros, and of course is going to share some even more interesting thoughts about e-commerce, cloud computing, and Optaros with the audience. Thank you very much, and Kevin, the audience is yours.
Thank you very much. Hi, everybody. I am also, I guess, remote today. I'm in a very foggy, sort of cold Boston today, so I hope everybody's doing well where they are. So good morning or afternoon to you. I wanted to start out with a slide that just shows a depiction of an architecture. And this is actually an Amazon slide, but the reason I wanted to start with this is because this will look familiar to those of you that have done some infrastructure architecture in the past. There's nothing incredibly different about this. There's different layers. There's web servers, there's load balancers, app servers, databases, tertiary services on the outside such as CloudFront and things like that, or CDNs. But the point here is basically that this looks very similar and is very similar to how you've thought about architecture in the past, with one important difference. And there's a lot of options that you can take advantage of in AWS that aren't available in a traditional environment. And probably chief amongst those is the ability to scale this in any direction very, very quickly if you properly prepare for it. So a couple of things I wanted to share up front just to set the stage for some later slides. Currently, the way consumers are buying is changing, and I know that doesn't come to a surprise to most people on this call. But if you take a look at what consumers consider the safest versus the most convenient and which way the trends are moving, currently consumers still consider in-store purchases being the safest with 77%, and only 7% consider mobile being the safest. However, if you go towards the most convenient, which almost always wins out, especially in the West, you have 68% of folks doing online PC purchases as most convenient, 38% mobile, and 13% in store. So obviously consumer preferences towards buying online and giving customers a great online experience is extremely important, and we'll get into that in just a little bit and what the effects of a bad customer experience can do to a customer's buying behavior. So mobile is an increasingly important channel, particularly tablets. 42% of mobile users browse products on a regular basis. I know I have an iPad and an iPhone. I tend to use my iPad a little bit more regularly. Folks with other tablets, Kindles, things like that they're here in the office use those tablets very regularly as well. 32% of folks on mobile read online reviews, and 23% of people have purchased on mobile in the last 30 days. And that's a number from Nielsen back at the end of last year, so those statistics have probably gone up a little bit. It's also important to notice that mobile share of e-commerce grew about 250% the year ended Q1 of this year, with iPads accounting for 2/3 of the shopping, and 90% of all mobile revenue is generated via tablets. So a couple of things to consider when you get into designing an architecture for the cloud. And again, I'll get into those points a little bit later in the presentation. So running e-commerce in the cloud, where do you start? There's a lot of things to consider, a lot of things to discuss, and a lot of things to align within your organization. So it's important to note that you have to think of your application as being architected for the cloud. And what I mean by that is you've got to decouple components so that you don't have two components that are so reliant upon each other that if one fails, the other one fails. So going back, probably 15 years, people talked about loosely coupled architectures. It's the same in the cloud. You just want to make sure that your coupling is done smartly and is fault tolerant, and that you're taking advantage of the ability to run various components, many more of them at one time, scale up and down, and things like that. We have like the concept of what we call a share nothing architecture, which is essentially making sure that there is no one component that's reliant on another component's data in order to maintain its state. So if you need to maintain state on an application side, there's various different ways to architect through this, but you shouldn't architect it in such a way that you have the bulk of your system, for example, reliant on one particular server or subsystem that's maintaining state, and should that fail, everything else fails. Some other things to consider when you're running e-commerce systems in the cloud is consider that mobile audience and that growing audience. Things like social APIs, people coming in through different channels into your e-commerce system. The reason you want to consider this is because you can get spikes in traffic based on, for example, a celebrity might tweet something about your company or a product, and that can cause a tremendous spike. So you might want to have certain channels segmented in the way that the traffic comes into the system, and you can do that very easily with AWS. So I want to get into a few best practices here. I think I've got 5 or 6 of them, and I want to start out with scalability. So scalability, you can look at it as horizontal or vertical. I want to talk a little bit about vertical scalability and what that is to put things in context first, which is essentially throwing more iron at the problem. So if you have a performance issue, if you're getting a lot of users and a lot of traffic, years ago you just threw a bigger machine at it and hoped that helped out. With AWS, you can still do that. You can instantiate a bigger machine, but it's better, in our opinion, to think of horizontal scalability, which if you go back to that original diagram of the architecture, it was one of those layers running across side to side there. So if you need more web servers to handle more traffic, then you can basically just start some up on AWS. Now you have to think ahead. You have to think, when you're designing the system, when I start a new web server, how is that going to, how am I going to start it up? How is it going to integrate into the network? You can pretty much scale any layer you want. So it's important to monitor each layer of the application, figure out, what your threshold is and what your tolerance is for latency, and then plan to scale at those levels. So when you're thinking about scalability, you can think of it proactively, which is trying to anticipate your traffic, your peaks, and planning appropriately. So if you have an event, say for like a private event retailing site, if you have an event coming up and you know that you're going to have 10,000 users hitting the site within an hour or less, you want to make sure that you plan ahead for that. That's a good time to be proactive in your scaling versus reactive. By reactive, I mean you get an alert that says you've got you reach a certain level or a peak in your monitoring, and you want to respond very quickly by bringing up another service or server. So proactive is always better because it's done ahead of time. Reactive is very quick on AWS, but you still might introduce some latency into the system if you're not quick enough. So best practice number 2. This is a really important one to us, and its performance is a business requirement. So I want to give everybody a few numbers here just to think about why it should be a business requirement. So I wrote a blog post back in April of this year called Impatient America. So these numbers are in there if anybody wants to reference them. Basically, it shows that people just aren't going to wait for your web page to render. People are very impatient, and they'll move on to other things. So a study done showed that Google response time, if it was slowed by 0.4 of a second, there were 8 million fewer searches per day. And there was a 25% abandonment rate for a web page that didn't render within 4 seconds. And on mobile, there was a 50% abandonment rate for anything greater than 10-second render time. So just to put that in context, to extrapolate on that a little bit, back in April when I wrote that, Amazon was making about $67 million in sales per day, which meant if they had a 1-second page delay, they could lose up to $1.6 billion in annual sales due to delayed rendering time. So if those numbers don't show that performance should be a business requirement, I don't know what does. And it's got to be something you think about early on when you're planning your system, when you're designing your system and your software, and not just when you go to deploy it. So there's definitely a proven correlation between response time and conversion. So how do you keep your response times quick? There's a couple of ways, right? You can cache at different levels. You can use things like memcache. You can use CDNs, such as CloudFront. Lots of different things you can do there. Other things you can do is build representative test cases and load test the system. Put it under some strain and see how things perform and plan accordingly. You also want to make sure that you're measuring performance metrics regularly and you're making changes based on what those numbers tell you. Another thing you can do is you can segment performance between server and between the client. There are some things, not everything has to be done on the server. You can always offload some things to the client of the user's browser through JavaScript. So again, this goes way back to planning long before you deploy. So it's important to think of performance through the entire development lifecycle and not just when you go to put the system into production. Best practice number 3 is to automate everything. And by that I mean take steps to make this as error-free as possible. There are tools out there that can help you requisition and instantiate new servers, things like Chef or Puppet. Basically, start thinking of infrastructure as code. What AWS offers is the ability to scale up and scale down very rapidly. And if you're trying to do that with a person actually, on the website doing it instead of doing it programmatically or in an automated fashion, you introduce the possibility of human error and delay. So automate what you can, and that should be as close to everything that you have. So think about not only ramping up servers, load balancers, databases, things like that, but also how you configure things across zones. That's very important as well. So configuration and environment management, things like are we running across multiple zones within Amazon? Are we running test environments, QA, UAT, staging environments that are congruent to the production environment? Also, you do want to think about server provisioning time as well. So while server provisioning time is very quick, you can still introduce some latency and lose some potential buyers in the process. So try to stay one step ahead of it, if at all possible, and set your checkpoints or your tolerance for latency levels a little bit lower than you might do otherwise, just to make sure that you give people the best overall experience that they can have. Best practice number 4 is capacity planning. And I don't mean this in a traditional sense of capacity planning. This is more, since Amazon offers you virtually unlimited capacity, you can scale up to just about any level you want to with AWS. Capacity planning in this context really serves to help you understand what you need, what you may need to scale to, and really what you're going to pay for. So with AWS, you pay for what you use, which is probably the single biggest benefit to it from a financial perspective, right? It's not that expensive to begin with, and you can scale up and down as demand dictates. So you want to err a little bit, in my opinion, on the side of extra capacity. So I wouldn't want to say wait until we have a big private event going on and we've got thousands and thousands of users, and all of a sudden everything starts pegging out at 100%. I want to go ahead and make sure we've got that capacity there. I might have it for an hour or two longer than I absolutely need it, but the benefit of having that capacity far outweighs the cost of those extra 2 hours of AWS usage. You can also mix planned and elastic capacity, meaning that you always have some base level of capacity that you want your system to have, not only for performance but also for reliability. So you want to think about doing things like multiple database servers. Obviously, having a single point of failure is a very bad thing, but you want to make sure that you are properly planning for redundancy and performance. But then as you have the demand, scale up, and that's the elastic part. And above all, just make sure you plan ahead and you work with other folks in your company that are planning marketing events, things like that, to make sure that everybody's on the same page. So when marketing decides that they want to run a big event, you want to make sure that you've already thought about it, already planned about it, or thought it through, already know what your expectations are for the number of users, and have appropriate capacity. Best practice number 5 is managing environments. So I've already spoken a little bit about how AWS enables limited capital investment. You pay for what you use. You can use it for a short time period or a long time period. You can also use it for development. We do. Systems integration, we also use it for that and for testing and production. So it's great. You can crank up a development environment when you need it. If you need another environment that looks a little bit different for testing, but it's essentially step up from development, that's real easy to crank up as well. And when you're done with it, you can shut it down and save money. In a traditional sense, that's really not entirely possible. So I think those are probably the top 5 best practices that we put in place here at Optaros. One more slide on capacity planning here, and I don't know how well everybody can see this slide, but there's a dotted blue line at the top that is supposed to be representative of a traditional infrastructure. So you might plan for some initial capacity, and then when you have a bump in the actual need, you go out and you buy some more servers and install those in a cage. And you can see the actual demand line is in red. So using automated sort of elasticity with AWS, you can follow that demand very closely, and you avoid those large gaps between your actual demand and the capacity of your environment. So what you're really seeing, the distance between the red line and the dotted blue line is really your cost gap. But even more alarming is when those two things are close, because then you might limit your customer experience, and it might not cost you more in terms of infrastructure, but it's going to cost you customers. Another one of my responsibilities here at Optaros is I'm also the Chief Security Officer, so PCI is very near and dear to my heart. I think it's important to think about whenever you're doing, whenever you're transacting on the internet, you have to think of security. So the quickest path to PCI is to always keep credit card numbers off of your network and off of your solution, right? So you can use third-party services such as CyberSource and other payment gateways to accomplish that. But if you choose not to go that route, you should know that under PCI DSS 2.0, which is the payment card industry spec, the second revision of that, they approved using virtual servers in the cloud for solutions that are PCI compliant. So AWS is SAS 70 and ISO 27001 compliant, and you can implement a PCI compliant solution on AWS. One other point to think about when you're designing a solution, and this goes all the way back to when you're choosing your development platform. You want to be aware of licensing. So there are many, many vendors out there, software vendors, that have licensing that works very well with AWS. They have what they call peak licensing. So if you scale up, you pay a little bit more in licensing. If you scale down, you pay less. There are other software providers that don't have that, and they work on a core-only basis. So let's say you have a situation where you're running a half dozen cores or more as your sort of base level, and then you want to ramp up to twice that. Some software vendors will actually ask you to pay twice your licensing fees, even if you use those servers just momentarily. So if you're in that situation, I'd suggest working with your software provider. This is an industry trend that's moving towards peak licensing. But work with your software provider to make sure that you're not going to get hit with large licensing fees if you have to scale up and down. And in my opinion, if a software provider can't provide that and you want to deploy in the cloud, you might want to look elsewhere for another software provider. So a couple of things you can do now. If you already have your solution deployed in a traditional environment, a couple of things you can do around testing and experimentation. You can spin up new QA environments very quickly for release testing. You can create load testing environments. This is something that we used AWS for early on and still do. It's a great use of it. You can see how an environment's going to respond to a tremendous amount of traffic. And it's not going to necessarily hurt your network or bind up your network or your servers. So great use of it there. Experimentation, you can test out new features. So you've got a code freeze going on and you want to test something out that might come up in a future release. You can deploy something on Amazon very quickly and test something out. You can also do A/B tests, and you can also enable social networking features outside of your production environment. So in that situation where you might have a celebrity tweet about one of your products or services, something like that, you can put an environment together on Amazon that would handle that traffic. Of course, you've got to think about things like, what's the endpoint that they're coming to and things like that. But that's fairly easy to do and can take a tremendous amount of load off of your servers. Another thing you can do is use AWS for production capacity overflow. So you already have a traditional environment. You're getting a lot of hits. Say, for example, people are coming in and browsing your catalog a lot. You can extend your catalog to the cloud. There's a number of ways you can architect a solution to do this so that you can take your read-only content and move it out to the cloud, move it out to a CDN. I know a lot of people already do that. But you can also move other things off to Amazon too to lighten the load on your traditional environment if you have one. Another thing you can do is create gateways for things like mobile APIs. So if you're developing a mobile application and you're unsure of how it's going to be used, you can have its primary integration point be in the cloud, and then do some, do its work there and integrate with your existing backend where necessary. So when Optaros thinks about an e-commerce ecosystem, we think of all three of these layers. On the top layer, we have all the customer experience areas, right? You'll say a storefront, you have mobile, you've got the shopping cart, community, marketplaces like eBay and Amazon. In the middle layer, you've got some enabling technologies like a product catalog. You've got some content management and administration going on there. You've got analytics data. And on the back end, you've got all the traditional back-end components of a commerce system, your order management, payment gateways, CRM, ERP, all those different things. So this ecosystem can be very challenging to understand and support because it's really at the intersection of strategy, creativity, and technology. And a lot of traditional players in this space haven't been able to cross between these issues well. One of the things that's remarkable about today's environment is the consumerization of back-end IT, such as AWS. It's really a disruptive change, and if you want to deploy in that environment, it really does help to start thinking about what that deployment means way back in design and before that in strategy. So a little bit about Optaros, a little shameless plug here. We are a digital commerce company. We develop and deliver systems at an accelerated rate. We've got a lot of experience with some clients that, some very big brands that I'll show on the next slide. But we cover all the areas that are very key to a successful e-commerce system: user experience, technology, visual design, and hosting and support. So here's a few of our clients. You've probably heard of some of these brands. And that's it for me. So I'll turn it back over to AWS at this point, and thank you very much for your time.
Great. Thank you, Simone and Kevin, for today's presentation. We appreciate your time. I'd like to open it up for questions. If you haven't done so, there's two avenues to ask questions. You can use the Q&A dialog box in your browser and submit your questions, and you can also submit questions to us via Twitter. The hashtag is AWS Optaros. And we have a couple questions to respond to. The first one came from Perry, and I'm going to direct this to Simone. What is the optimal web technology used for AWS sites? He asks, am I required to use Java, or can I use .NET?
Yes, sure. So Perry Nelly sent us this question via Twitter. So hello, Perry. You can actually use multiple different technologies to develop on AWS. We have a section for developers where you can access the SDK for multiple languages such as Java, .NET, Python, PHP, Ruby, etc. So you can essentially select the language of your choice and then download the SDK. We also have a toolkit for Eclipse, which is very popular among Java developers, as well as a toolkit for Visual Studio, which is, of course, very popular for .NET developers. So you can essentially develop on almost any type of programming language and technology that you like.
Terrific. So we have another question that I will point to you, Kevin. What types of database architecture do you use for high-traffic sites?
So to me, it's more about how you design the database and deploy it than anything else, right? I mean, it's not the specific database like any particular brand, if you will, of database. So it's important to think about how much of your data is going to be really read data and how much of it needs to be write enabled. So obviously when you're doing things like inventory management or you're processing an order or something like that, that's going to require some level of locking within the database to do that atomically. So if you can think about architecting your database so those things are as partitioned as possible and placing the high volume read data on a read replica or potentially more than one read replica in two different AWS zones, that'll improve your performance tremendously.
Great. Thank you for clarifying that. The next question is for you, Simone. What about Amazon.com website? Is it running on AWS?
Yes. So the Amazon.com website, as well as all the others regional websites, are running on Amazon Web Services, and a big part of the Amazon.com backend is also running on Amazon Web Services. So as people say, we eat our own dog food.
Great. Kevin, I'll direct the next question to you. Have you or your clients experienced downtime with AWS?
So when you think about downtime, I mean, I think no environment is, absolutely bulletproof. And as Simone pointed out, I can't remember how many nines, but there's a bunch of nines that AWS can deliver. But it really comes down to, again, how are you architecting your solution? If you go into an environment where you have, a single server, whether it's real or whether it's virtual, and you're not thinking about things like failover, and you're not thinking about things like high traffic and latency and the potential for software failure on one node or one subsystem versus another, you're putting yourself in a position to experience more downtime than necessary. So, yes, we have had, virtual servers on AWS, go offline on us, and sometimes it's been for, because of our own bugs in software that are just, the nature of the beast. So you've got to make sure that you architect for redundancy and built in things like fault tolerance and things like that.
Great, thank you. The next question, which is along the same lines, is Kevin, I'll direct this to you. Is AWS secure enough?
So I think it absolutely is, right? So asking whether something is secure enough really depends upon the context. So, if you're storing usernames and passwords in clear text, it's no more secure than it would be in a traditional environment, and no less secure either. So when you think about security, to me, it's less about the platform than it is in how you treat the information. So AWS doesn't offer any intrinsic security above any other environment that you might already have. If you configure it appropriately, it'll offer as much security as anything else. There's nothing automatic about security. It really comes down to your procedures and policies around this, and making sure that they're properly implemented regardless of the environment that you're deploying on.
Thank you for clarifying. Another question we have is, and I'll direct this to you, Kevin, as well, is have you achieved PCI compliance for an e-commerce implementation that's running on AWS?
Yeah, so we have. We've got a number of clients that are running on AWS. And we like to, as I mentioned earlier, we like to try as much as possible to take PCI out of scope, meaning that we'll partner with a third-party payment provider where we can use silent order post or some other technology like that to keep credit card numbers and credit card data in general, not only off of our servers, but from ever traversing our network. Integrating with a payment provider in that fashion, that essentially takes the PCI difficulties completely out of scope, for the merchant. So if you're a merchant, that's PCI is on your plate, and that's something that you should consider. If you're an integrator or a solution provider, you're certainly going to affect that merchant, so you should understand those challenges and make sure that you're offering good direction in that area.
Great. I think we have time for a couple of more questions. So if you haven't submitted your questions, feel free to, again, using Twitter, hashtag AWS Optaros, or use the Q&A in your browser. The next question I'll direct again to you, Kevin. You're popular today. Can you share more information around how does Optaros work with clients once cloud hosting has been implemented?
So we offer support and hosting services, and obviously if we're hosting something with Amazon and AWS, there's a couple of different aspects when it comes to actually supporting the solution. There's sort of a DevOps component that's about making sure that configuration is proper, that we're looking at metrics across the system in a variety of situations to make sure we have the environment tuned. From an application support perspective, we obviously offer break-fix support, enhancements to the environment, things like that. So when you deploy an e-commerce system, it's rarely going to be one size forever, right? So obviously every e-commerce merchant wants to be able to scale and increase revenue, and there's pretty much a direct correlation between increasing revenue and being able to scale to keep up with demand. So at Optaros, we offer a breadth of services after a solution is deployed that cover both application support and DevOps support to make sure the environment is stable and capable of growing as needed.
Great, thank you, Kevin.
I just got a question from Perry directly on Twitter. So let me quickly read the question and answer it. So Perry is asking, is there an FAQ for designing the decoupled modules? Just trying to figure out how I would design the site to be decoupled. I think it's a very interesting question. We have a section on our website, the AWS architecture. You can just go to aws.amazon.com/architecture, and there you will find a lot of white papers or material that you can use to understand how to architect properly. And of course, decoupling is one of the main principles behind a robust web architecture. So that's where you should go, Perry. Thanks for asking.
Great. Well, I think we have time for one more question, and I'll direct this back to you, Kevin. Are any of your Optaros clients currently using AWS?
They sure are. We have 7 clients running on AWS. Most of our clients have asked us to keep information about how they're deployed private. I'm sure most people can understand that, but I can mention 2 clients that are deployed on AWS with their permission. One is Medwins, a European company, and another is Bloomingdale's. We did the flash sales for Bloomingdale's, and that's all run on AWS.
Thank you, Kevin. So that wraps up today's presentation, and I'd like to again say a thank you to Kevin and Simone for your time and your insights today, and I'd like to thank everyone for attending today's webinar. We will send out an email with a link to this recorded presentation, and on behalf of Amazon Web Services, the entire team, and our presenters, thank you for joining us today to learn more about running e-commerce on the AWS cloud.
Thank you very much.
Thanks a lot, everybody.